Good morning.
Let us pray. Loving Father, King of glory, we want to thank you for the gift of life. We want to acknowledge you for your goodness, and we want to thank you for this day. Loving Father, as we dive into a new day to create our new generation, we want to call upon the power of your Holy Spirit to come and guide us, come and be with us. Father, whatever is going to be taught, may you send your Holy Spirit to guide us so that we can understand it and we put it into consideration. We want to call upon you to strengthen us and drive away the fear in us in accordance to academics. We believe that before even we pray, you know what we want. Father, we want to ask you, may you make us succeed in whatever we are going to do so that we can get from this program. We pray to expecting much from you. In the mighty name of Jesus, we have prayed and believed.
Amen. Thank you so much, Edward, for the word of prayer. Good morning, everyone. Thank you so much for joining. Thank you so much for keeping time. Today in our lesson, this lesson is going to be linked to what we covered yesterday. And today we are going to concentrate on what we call the ratio theorem. So your heading for today's lesson should be the ratio theorem. And for those who are joining us for the first time, this is our fourth lesson this week. So when they talk about the ratio theorem, we are going to be looking at how can we find any position vector for any point along a line. It can be internal or it can be an external line. Sometimes, let me say, sometimes in construction, you may construct something and the time comes when you want to make an extension. Sometimes it may be something within, like maybe you have seen people after constructing something, but they want to construct something in the middle of something. So those are some of the things we shall look at under. So there are two things that we are going to look at. We are going to first look at what we call the internal division. Internal division, like you hear the word internal, it means within. And what are we going to look at? When you look at my screen, let me, uh, when you look at my screen, you notice that we have a vector diagram. And our vector diagram, you notice that we have our vector O to A, and our vector O to A is given by A. And we have our vector O to B, and O to B is given by B. Now this point C along the line A to B is what we call our position vector of C. And our major area of focus is how can we find a vector OC simply or in simple terms. Now they have given us that the ratio from A to C is M. So that means that from A to C here, I'm going to have M. And from C to B is equal to N. So from C to B is equal to N. So that's what has been given to us. Now, if we are interested in obtaining our value for C, we have two approaches we can use. I'm going to first use here the first approach, and then for you, it is up to you to pick any approach of your choice. But all the approaches will lead us to the same answer. And what is the first approach? We know very well that in order for us to get our vector O to C, this is our vector O to C, someone can move from O. Remember we said that always start from the first letter from O. So someone can move from O to A. So I can move from O to A. And then from O to A, I can come and I move where C is. So I can move up to A to C. But another person can also decide to use this route, that to move from O to C, I can move from O to B, and then I go to B to C. So that one is also very, very fine. Whatever path you use can lead you to the answer. But you notice that in order for us to get SC, we need to know what is our A to B. So that is the first thing we are going to find out. What is our A to B? But if I may continue, this means it is O to C, and O to A is given by A, then plus A to C. But when you look at A to C covers the has M parts of the whole line of A to B. So here I can say that this is O to C, which will equal to A, then plus A to C has M out of M plus N, but of the whole line A to B. Kindly let me know through the chat whether that one is clear. What I've put on, whether that is clear. Okay. People are saying, yeah. Yes. Because when you look at this line here, has been divided in the ratio of M to N. That means that from A to B, it has M plus N. That is the total ratio. When you look at our total ratio is equal to M plus N. But only from A to B, this part here has M parts, but of the whole ratio, which is M to N, of the line A to B. But what is our A to B? So you can note that to get our AB, like we said yesterday, AB means O to B, then minus O to A. But what is O to B is B, then minus A. So that means that in our equation here, where there is A to B, we can put B minus A. So that means that our O to C is going to become A plus M out of M plus N, then into B minus A. So your next part here on what to do is for you now to open the brackets. So I can say this is A plus, when you open up the brackets, you have M out of M plus N times vector B minus M out of M plus N vector A. So we are going to collect like terms. The A's and the A's can come together. So I'll have A minus M out of M plus NA, then plus M out of M plus N of B. Now, when you look here, you notice that A is common because it is a vector. So I can do it here as side work, and I say A minus M out of M plus NA is the same as having you can remove the A, no problem, or you can factor out A. And when you factor it out, you get 1 minus M out of M plus N. Alternatively, in case you don't use this approach, for you can say that this is like out of 1, then you get the LCM, which is M plus N, then get this LCM multiply with A, so you get A into M plus N, then minus this one divided by this, still remains 1, then times that one, which is MA. So when you go on, you notice that when you open the brackets, you get AM plus AN minus MA, everything out of M plus N. So you notice that this AM and this MA, they can reduce. So you remain with AN out of M plus N. So the whole of this one is going to reduce into AN out of M plus N, then plus MB out of M plus N. And this is our vector O to C. Can you let me know through the chat whether you have understood up to that point? Okay. Okay. A bit okay. Okay. Yeah. Very well. Okay. Now, this is the one approach. This is one approach. Now, let me write the second approach. And then we are going to choose which one you want to use. I'm going to write the second approach. Now, the second approach I want to use is that we have from our ratios, we have A to C, C to B equaling to M to N. You know very well that in ratios you can divide. So this is like having SC out of C to B equaling to M out of the N. So what can I do? I can cross multiply. This one comes this side, this one comes this side. So that means I can have NSC, which is our vector, equaling to M, C to B. But we know very well that from our vectors, whenever I have A to C we said means OC minus O to A. So that means here I can say this is N into OC minus O to A. equals to M into OB minus O to C. So open up your brackets, you get NOC minus NOA equals to MOB minus MOC. So now you notice you have a C, you can put them on one side, and the other you put them on the other side. So I can have NOC plus MOC equals to MOB plus NO to A. So here OC is common, I can put it out, so I remain with N plus M equaling to. Now what is here, I can write NOA plus MOB. It is okay, I've interchanged. I've just wanted to start with A then B. But we know that O to A from here is equal to A, so I can say this is N of A plus M of B. And here I have O to C into M plus M. But what am I interested? I'm interested in OC. So I will divide by N plus M, divide N plus M, divide by N plus M. So I remain with my O to C equaling to N out of N plus M of A, then plus M of B out of N plus M. Now, what you see here and what you see here is what we call the ratio theorem. That is what we call the ratio theorem. So you can use any approach. I don't know whether you have picked the second approach as well. Jordan says it is more better. Okay, better. Yeah. So any approach that is easier for you is what you use. But at the end of the day, okay, Judith says, okay. Yeah, so you used any approach. Okay, Sharon says it's there. Okay, yeah. Now, use any of the approaches and maybe let me first allow you to write something. Let me first allow you to write something. Yeah. So you can first write or you can take a screenshot. So now, whenever they give you a given ratio and they want you to obtain the vector, any vector that lies along the line but internally, this is how you're going to be finding it. N and M is the ratio, so they may give you 1 to 2. So for you, just substitute here in this, and then you go on. And this is what we call the internal division of a line. It will depend on the textbook you are reading. In some textbooks or in some books or in some pamphlets, when you are reading, you may find that they have not used the M and N for the ratio. I know there are some books you are going to read, and instead of using M and N, maybe they have used mu and alpha. It is still the same thing. For you, just come, you say OC is equal to where there is N, is the lambda A, then plus mu B. Even in some books, they write it like this. So don't get confused. It is the same thing. Because when you look at the two, you notice that the LCM is the same. So in case you find something like this, still it is the same ratio theorem, but in a simplified form. Yeah. So it depends on the ratio they have used. In case they have used the mu and alpha, it is okay. In case they have used that, but all of them are the same. So you get the ratio times the vector, ratio times the vector, then everything you can say out of that total. Members, are we good to continue? Okay. Okay, people are saying we are good to continue. So I'm going to clean my screen and then we go to the next one. So that was internal. Now, what about external? External means that you have gone beyond, like the way you see at our homes, like when you have, let me say, a house, but now you have decided to make an extension beyond. That's what we call the external division. So external division means that you have gone extra, you have gone beyond. So that's what now we are going to do. Now, a line can either be divided internally or externally. Now, the only difference with external division is the ratio is negative. So when you look here, you notice that our A to C is negative M. So A to C is going to be negative M, and then C to B is equal to N. So C to B. So that means that from here up to here is where we have our N. Now, you are going to allow me, since people said the second approach was a bit easier, allow me to use that one. So I'm going now to come and say our SC to C to B is the same as negative M to N. In other words, whenever you find that your ratio is negative, it is an indicator that that one is an external division, even if they have not mentioned it. But also in the question, if you see that they have mentioned external, then you go on and put a negative on the ratio. So we are going to say this is SC out of CB is equal to negative M out of N. So what are you going to do? We do the cross multiplication. So that means I have NSC equaling to negative M of C to B. These are our vectors. Now, what are we going to do next? Now, we go back and define that A to C, we said from yesterday, is the same as OC minus O to A, is equal to negative M. And we know CB is the same as O to B, then minus O to C. Then you can now open your brackets very well, or you can first substitute, there is no problem. Because you know that O to A is A, O to B is equal to B. But you want to find what is OC in terms of A. So when you open, you get NOC minus N of OA is equal to negative M OB minus, which negative and a negative will give us a plus O to C. So the next thing you do is to collect like terms. This one being positive, once it comes this side, it becomes negative. So I will say NOC minus MOC is equal to negative M OB. Then this being a negative, once it crosses, becomes a plus, plus N of OA. So what am I going to do? OC and OC is the common vector. So that means I can say N minus M, everything into OC is equal to, you are going to allow me here, I start with a positive and then I end up with a negative. So I've brought OA first, then I brought N. So the next thing you do, you divide. So it means that your OC is equal to N out of N minus A of OA minus M out of N minus M of O to B. And then you can substitute what is your OA and what is your OB. So here we shall end up with N out of N minus M of our vector A minus M out of N minus M out of our vector B. And this is our O to C. Now this is what we call the vector the ratio theorem for an external division. In some books, depending on the book you're reading, you may find them when they have just combined them, when they have said NA minus MB, everything out of N minus M. That is also very, very fine. Yeah, in simplified form. Members, are we on the same page? Okay, Gilbert says yes. Sharon says yes. Okay, Prince says yes. Okay, yeah. So this is what we call as the external division of a line. So whenever something is divided externally, the only difference is that negative. That one of the ratios is negative. Okay. Are we good to continue? Maybe let me first check on Bettina. Bettina, if you could tell us, it seems Bettina, if you could unmute. Okay, I failed to get Bettina. This is Modric. Yes, Bettina? Modric?
For me, I kind of just try and say external divisions.
Morning, sir.
Bettina, your network is not clear, but the only word I... Yes?
Good morning, sir.
Okay. Bettina, I think it is your
Is
network.
it so?
Maybe you... Hmm? Okay. Bettina, I'm not getting you clearly, though I heard that maybe you came in a bit late. Yes, Modric?
So I'm begging your pardon on the negative sign on the ratio of m to negative m to n.
Yeah, like we have said that if something is divided externally, it means that it has gone beyond its boundary. So whenever something goes beyond its boundary, we put a negative. So that's why we have putting a negative on the ratio to show us that now it is beyond its boundary.
I'm good to go.
Okay. Yeah. Okay. Now, for those people who are going to do things in surveying, things in architecture, there is an app or there is a software that they use. Now, these things are applied in those software. That software is called CAD. 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 It stands for Computer Aided Designs. I know some of you have seen construction buildings. You have seen things that have been designed, like those buildings and what. And sometimes when they're drawing these plans, like you may have finished to construct a building, but you want to make an extension, what. So you go in that software and then you do the mathematics to know how far you have to go, where not to go, the limits. So now those applications, I'll show you some of the applications at later. But now, how can we summarize? We are going to come up with a simple summary such that you do not cram the what? The formula. So I'm going to come up with the summary and then it will help you, I think. Now, in case this is our point A and this is our point B, and this is for internal division. If this is our point C here, and our ratio is m to n, let me say this is m and this is n, and that is the ratio they have given you. What do you do for the formula? So for you, what you do or what you need to know that when you are working with the ratio, this m will go here and this n will go here. In other words, hope you have seen what I've done. So in other words, what do you do? In order for you to get O to C, for you, you will know that M goes with a B. So you can say it is okay to start with N. So I can start with N. I can say that N goes with A. So you say this is NOA out of the ratio. The addition of the ratio, M plus N. Then plus this M goes with a B. Then you say M O to B out of the addition of the ratio. In case it is external, it is also K. In case, let me say, this is A, this is B, and this is C. Remember, for external, the only difference is that one is negative and one is negative and the other is positive. So you do the same. In other words, in case this is negative m and this is n, then you know that now I'm going to have this negative m go here and this n will go with the a. Then you say that now my ratio of O to C is going to be n goes with the a. Then you say n of OA. Then you add the two ratios, which is negative m plus n. Then plus you have this one, which is negative m with O to B out of negative m plus n. So that is the summary you can use. As long as you know that the ratios, you add them. In case they are negative, you still add them. Can I assume that is clear, members? Okay, James says yes. Yeah, Bobide is asking, can I make a negative? Yes. When it comes to external, whatever thing you make a negative, it is okay. It works. Eh, eh. I repeat, let me repeat one more time. I've said that if this is our line A and this is B, and I have divided our line C, they will tell you that this line is divided in the ratio of this. So for you, what you do, this is M and this is N. Those are the ratios. So for you, what you need to know that this M goes with B. This N goes with A. So in case I want to get O to C, I will come and I say N goes with A. So I will get my N times my vector OA. Divide by the total of the ratio. Then plus this M goes with a B. So I will say M of OB divided by the total. The same thing happens. In case this is negative, if in case it is external, for you what you do that, one of these ones, just make them a negative. So the moment you make them a negative, it means that where there is M, you just put negative, negative, negative. Yeah. I think on internal. Oh, in the first internal summary, I thought I'd used N. Okay. Hannah, is it clear now? Hannah? Okay. Hope we are good to go now. Oh, maybe I might have missed N. Okay. Okay. So this is like the general formula. Yes, you need to know. For external, it's just a matter of you knowing that for external, one of them is negative, when it comes to the ratio. One is negative. So let me now ask you. Let me hope I have my table here. Now, these are some of the practical applications where they are being used. Things like road construction, land surveying, engineering design, and urban planning. So whenever you hear that they want to make something to boundaries, they want to place even like this national water. Whenever they want to place, let me say, a valve, a control point somewhere, it's not that they just go and say, let us put it here. No, there is some mathematics they have to perform in order for them to know that once we place here, once we put the control valve here, the pressure this side and the pressure this side is going to be balanced. Otherwise, if you just place it anywhere, you may find that some areas get water, other areas do not get water. So such things are done through use of these ones. So in case they draw a very long line, maybe they have put a pipe, a very long pipe of water, and they want to know where should they put the control, because also you know that it's very dangerous if you don't have a controller somewhere, because in case of anything, you may lose a lot of water. So in order for them to know that, let us place it here, then they have to first perform. And now such performance is what we call the internal. So they have to know where should we place it such that the balance in pressure of water is okay. Yeah. So that is what they always do. Even when it comes to these buildings, like in case they want to make some extension on any flat or anything, these things are being applied. Now I'm going to call this number 1. This is going to be number 2. This is number 3, and this is number 4. We are going to respond through the chart. I want you to put in the chat the type of division this is. By type of division, I mean either it is internal or external. Now in the chat you put for us number 1, you just put I. Number 2, you say maybe external. Number 3, like that. So you place your answers in the chat from number 1 to number 4, and you tell us. One, people are saying internal. Okay, that is good. 2 is external. Okay. 4 is external. Mhm. Okay, okay, okay. Can we have someone throw some light on 4? Eh, someone, you can raise up the hand and you tell us why people are saying it is external. Hmm. Okay. Yes. Don't know how to pronounce your name, but MHE. You can unmute.
So good morning, Master.
Yes, good morning.
3 is external because when you write the ratio in fraction, it's 2 over negative 5, but the negative goes up. So it becomes a negative ratio. So it is external.
Okay, thank you. How do you pronounce your name?
Melissa.
Oh, okay, okay. Thank you, Melissa. Okay, Anyone to say something about number 4? Melissa has told us about number 3. Okay, yes, Gilbert.
I think number 4 is external.
Why?
Because looking at it is like they made an extension like on 2 sides, according to what I see. They made an extension on 2 sides, making them to have negatives. Both.
Okay, okay. Thank you for that. That was Gilbert's opinion. IFC.
Okay, personally, I think it's internal because if I was to put that to fraction form, it would be a positive. So it makes it internal.
Okay. Thank you, IFC. Then Ruth.
Okay, also my answer is related, but I also think it's internal because first of all, when you put it in fraction form, the negatives cancel, but also since it's a ratio theorem, and for some reason we have to relate two parts. We cannot have two negatives outside a point we don't know. So once there is a negative on this side, because it's outside our restriction, and then a negative on the other side, it means that in between -2 and -5, there is just a point, making the whole maybe illustration be an internal division rather than an external one. Yeah.
Okay. Thank you so much, Ruth. Martina.
Okay, yeah, personally, I think it's going to be an internal division because, like, okay, I'm looking at it practically. If we put -2 out of -5, the negatives are going to cancel and we remain with a positive. So, yeah, I think it's going to be an internal division.
Okay, thank you, Martina. Yeah, so members, you'll agree that for the first one, it is the internal. The second one, it is external, and this is an internal. Yes, like the explanations they have given you are all correct. These two negatives can cancel. So the moment they cancel, you remain with a positive. So which qualifies to be an internal. Yes. Okay, so we can start with some numbers. So this is our first item that we are going to look at. So they are telling us that we have A and B for 2 points with position vectors. So you feel free always to first say, now my position vector O to A is given by 2A plus 4B. And I have my position vector of O to B, and it is given by 2A minus 8 of B. Now, they are telling us that find the position vectors of the point which divide the line segment joining A and B in the ratio of 1 to 3, internally and then externally. So I'm going to first do the internal, division. In case you want, you can make a sketch. So in case I'm to make a sketch, it's like I have something like this, whereby this is O, this is A, and this is B, something like that. But our O to A has been given as 2A plus 4B, and our O to B has been given as 2A minus 8B. Now, since they have not given us that point, it is always a good practice for you to label it and say that let C be the point which divides the line segment AB in the ratio 1 to 3. Yes. Even if you don't say internally, as long as you have left them as positive, it will mean it is an internal division. So after doing so, it means that your C is somewhere here. And you know that now this is 1 and this is 3. So like I've told you, there is no need for me now to go back and cram. I can just come here and I know that this is my A, this is where my point C is, and this is where my B is. So our ratio has been given as 1 to 3. So that means that this 1 is going to go with the M, and then this 3 is going to go with the A. That is the meaning. If you want, you can first write your formula. But if you don't want, you can just start there and then. So that means that to get our vector O to C, I'll come and I say O to C will equal to, remember we said this 1 goes with the B, the 3 goes with the A. So that means I can say this is 3 of O to A divided by my vector, which is now the addition of the ratios, which is 3 plus 1. Then plus this 1 goes with the B, which is now going to be 1 of B divided by 3 plus 1. Members, is that still clear to everyone? Hope we are still on the same page. Then when I reach here, okay, it is clear. When I reach here, I know my O to A. So I'm going to say this is 3 into O to A, which is 2A plus 4B. Divide by 3 plus 1, which is 4. Then plus my 1 times OB, and my OB here is going to be 2A minus 8B, everything out of 4. And you know that from your mathematics, that since the 4 is the same, I can have it out. So here I'm going to open the brackets. I say 3 times 2, which will give us the 6A, plus 3 times 4, which will give us the 12B, plus 2A minus the 8B. Then the moment I reach here, I open up the bracket, I collect the like terms. 6A plus 2A, members, it will give us the 8A. 12B minus 8 thing, it will give us the 4. So here we shall have the 4B, but everything is divided by 4. Now here you need to remember is that you can first separate, because some of you have that tendency of just dividing 1. So here it is better you say 8 out of 4A plus 4B out of 4, such that you end up with your answers 2A plus the B. So this is our vector O to C. Yeah. Members, is that okay? Are we still on the same page? Yeah. Okay. Okay. So that is how you obtain your vector. So that is the internal division. But also I want to let you know, even if you had put here B and you put A the other side, still you come up with the same answer. Okay. You can let me know after writing whether we can continue. Will is saying continue. Yes, teacher, let's go. Okay. Now we are going to go to the second part, which is the external division. So still the first thing you do, you let. So you say, let D be the point which divides the line segment, AB in the ratio. Members, which ratio do you want to use? And please take note, because this is A and this is B, this is the thing. So you can have an extension this side, or you may decide that you have your extension this side. So whatever side you want. So you can either say let 1 be the negative, or you can say let 3 be the negative. So which one can we make the negative? You can just let me know. People are saying we make 1. People want to make 1. So we are going to say in the ratio -1 to 3. Yes. Yeah. So you can make any. Feel free to make any the negative. As long as 1 is negative, we shall come up with the same answer. So when we reach here, we are going to come back and say, now this is our this is our A. This can be our B, and this one can be our D. It is very okay. But even if you just go back to the formula, the only thing I want you to take note is that one is negative, another is positive. So in case you decide to do it like that, you can say this is -1, 3, as long as you know that the 3 is going to go with this, and then the B goes with this. So I'm going to come here and I say that our vector O to D is going to be, we can start with a positive 3 OA divided by, remember you are adding the 2, so it will be -1 plus 3. Then the negative goes with the B, so I will say plus -1 of O to B divided by -1 plus 3. Oh, okay. Sorry, Gabby. We are going to go back. So here we are going to substitute. So we shall have 3 into O to A, which we had as 2A plus 4B, divided by -1 plus 3 will give us a 2. Then plus, here is -1. Then we have our OB as 2A minus 8B, everything divided by 2. So what the next thing we do, we open up the brackets, 3 times 2, which will give us the 6A plus the 12B. Then everything is out of 2. But here, there is no problem. You can even say everything is out of 2. Because this 2 is common, then here -1 times 2 will give us a -2A. -1 times -8 will give us a +8B. So the moment you reach this point, then you collect like terms. 6 minus 2 gives us a 4A. So that means we shall have 4A. 12 plus 8 will give us, that is 20. We shall have our 20B. Then everything is divided by 2. So this one will give us 4A divided by 2 plus the 20B divided by 2. Remember, these are the vectors. So we end up with 2A plus the 10 of B. So that is our vector O to D. So that is how we obtain it. Yeah, you can either, even those I know who have used -3, your answer should be the same. So for whatever thing you have made, you get the same answer. In case you have used -3, you can share with us, but your answer should be the same. When you use -3, it means your extension was towards the B. In case you use -1, it can be towards the A. Hey, Shiba, when you look at the question, you notice that the question asked internally and externally. I don't know that Shiba you have been able to see it. So that's why now we are doing the two things. Okay, thank you, Mobi, for sharing. Shiba, have you been able to notice that the question told us that The question told us internally and then externally. Yes. Okay. So I'm giving some 1 minute. The answer is the same, Gabi. Yeah. The answer is the same. So, Edward, you can try out and see. Aaron, this is vectors. You let me know through the chat whether we are good to continue. Yes, Samuel, use the formula. It is what we are using. We are using the formula. But the only thing I want you to know that at A level, the formulas are many. The formulas are many. So you may not be able to cram all of them. And yet you still have more to go. Okay, just see, I'm going to go back and you take a screenshot. So just see, I'm going to go back. Yes, Frank.
Yes, sir. Good morning, sir.
Morning.
Yeah, I'm just wondering the final answer, like where you have 2A plus 1OB. Is it necessary, like, to write that one?
That is 10B.
Okay.
Eh,
Okay. Yeah, it's fine. I've got it.
okay,
Thank you, sir.
okay. Okay. Okay, I'm just taking back here for you to take a screenshot. Aaron, this is not Mecan. This is not Mecan. This is like pure. This is pure math. It's not Mecan. Okay, let me up just say you have taken a screenshot. Okay. Can you first read through? Can you first read through? The pure mathematics has a lot of application in the physical world. So many of those applications come from like physics, from those physics ends. Even in the biology world, because like mathematics is like a language of science. So for applicability, you'll find that applications are going to come from biology, they're going to come from chemistry, and they'll come from physics. And a few can come from economics. So the scenarios can rotate around any of those subjects. So members, do we want to first try this? Why don't you first try it also? But we can make the summary together and then we try it. So they have told us that we have a civil engineer that is planning the construction of a straight access road between two locations. Feel free for you to first come up with your simple sketch. Say, this is my point P and this is the load PQ. The position of these locations are given with respect to a fixed origin, where the position vector of P, this is P, so its position vector, O to P, I'm going to write it in a vector form, is -7, -13. In case you don't want to write it in this way, you can write it as -7 I minus 13 of G. That is very fine. And the one of Q, which is OQ, you write it in any format you want. It's -1, -3. Or someone can write O to Q as -I minus 3 of G. So any format you want, you write it. To install a service facility along the road, the engineer needs to locate a point that divides the line segment PQ in the ratio of 1:7. Now, the moment you look at the ratio when it is positive, that is an indicator that the point they want to install is an internal point. So that is why we are going to come here and we shall place our point here. because the ratio is positive and that means it is an internal. So that means that that service point you are going to let it. So you can say that let maybe C or let R, any point you want. Let me say let R be the service first be the point for the service what facility. So you let that be the point which divides PQ into this and this. Yes. So that is the only thing you need to do. So now you need to know that this one can be 1, this one can be -7. Members, are we trying it out on our own? Maybe I'm not getting you because I showed you how to get the formula. I showed you how to come up with the formula. So I'm not getting what you're trying to mean. Fixed origin means the reference point, means the origin O. That is the meaning. So it means that the measurements start from the origin. That's the meaning. Yes, Martina?
Okay, just an observation. When I'm looking at the question we have just done, they said, they said a thing, then they said, the line segment joining AB in the ratio 1 to 3. So is it a must that A has to go with 1 and B goes with 3? Like in this case, 1 goes with P and then Q goes with 7, or I can interchange them? Because when I'm seeing here, if I was to cross, 7 would go with P and 1 would go with Q.
Okay, now you look at how they have labeled the line segment. In case they say P to Q, then you follow that. Martina, I don't know whether you're getting it. Martina?
Yes, teacher. Thank you.
So you follow like how they have labeled the line. Yes, I think Lugema, you may have come in. Yes, it is the same approach. The only difference, the formula is the same. The only difference is that one is negative, another one is positive. Maybe Martina, you can give us the formula
Okay, when
that
I'm
you are
looking at
using.
it, I said OR
OR
is equal to 1 OP.
1.
OP. No, sorry. Yeah, 1 OP.
Have you used P to Q?
Yes.
Uh-huh. So have you done something like this?
Sure, I have. That's why I was asking whether like I should look at the question, because when you do it like this, 7 will be attached to P. But when you look at the question, like if you look at it at ratio form, P would go with 1.
Oh, now
Yes.
this one, you go back to the formula. If you come back here to how we derive the formula, I don't know that I still. Let me take you back here. You notice that here, A was going with M. Are you noticing? A was with M and
Yes.
N was with B. But in the final formula, you notice that they interchanged instead. That A came with N and then B went with M.
Oh, okay. So if we go back,
Okay.
going to be 7 OP
7 O P.
P
Good.
out of 8. It's 7 plus 1, which is 8. Plus, I don't know if I should say 1 OQ, but yeah, OQ out of 8. Then we substitute. I was writing as negative 7i and then negative 3j. No, negative 13j. So negative 7i minus 13j out of 8. And then negative I minus 3j out of 8. So since like the LCM is 8, then I will put 7 multiply. So it's going to be 7 times negative 7, which will give us negative 49i minus negative 91j. And then positive times negative I and negative 3j. Then someone would collect like terms and yeah. So it would be negative 49. It would be negative 50i minus negative 94j out of 8. Then you're going to separate them. Negative 50i out of 8 minus 94 out of 8. So when I simplified, negative 50i I'll divide by 8 is going to give me negative 25 out of 4 I, and then negative 94 divided by 8 was giving me negative 47 out of 4j. So I think we can simplify since we're saying like the denominator is the same and say negative 25i minus
This
4.
was 4, eh? Okay, sorry.
Yeah. Negative 25i minus 47j, or everything out of 4.
Okay. Okay. Thank you, Martina. Okay. Okay. Yes, Ruth?
Which I have a question in this last part, the second step, the second step. Okay, Kati, what if I don't use IJ notation? Because there's a principle I think I've forgotten that I confuse with fractions. So if I don't use IJ notation, does 7 out of 8 affect, how can I say it? Is it 7 times negative 7 and then 8 times negative 13? Or
Like
it,
this?
yes. I'll put here 7 out of 8 on this other side.
Here. Okay, Okay,
So how do I patch it up to now get this third step?
So you like now the whole of this you are going to consider it as a fraction. So we shall say negative 7 times 7 out of 8, then negative 13 times 7 out of 8. So you end up with negative 49 out of 8 and negative 91 out of 8.
Oh, okay, I've understood. I was putting a what? A bar in between this vector.
Okay.
Thank you.
Okay. Now, when you look very clearly to the item, you notice that they told us where the position vectors of P is this and Q is this. Now, when you look here, you notice that they gave them to us as as coordinates. So here in your conclusion, it would look much better if also in your conclusion you give it, you leave it as negative 25 out of 4, comma, negative 47 out of 4. Yes. since they gave them to us like the question gave them to us in form of what? Coordinates. So at the end of the day, after getting your ratio, after getting your OR, you can put them in form of a coordinate. Members, are we on the same track? Okay, Melissa, now that's okay. Okay. Let me first speak. Yes, Namata. Namata, unmute. Oh. Yes, Namata.
Sir.
Yes.
Okay, sir, for me, what I'm trying to say is that you first pardon that question. There is a way I'm not getting it, and like you're moving faster.
Like you have you understood internal division?
Yes?
Like have you understood what you call internal division?
Yes, I've understood.
Like which part is like disturbing you?
Okay, so for me, the part that was disturbing me, it's the part of ratios. First of all, so when you take a look at the OP, that OP vector where you wrote -7, and negative, I see like it's -13, and here when we were working out OR, we have 7, 0 OP out of 8 plus OQ out of 8, and I'm not getting that part very well. So
Where here?
what I was saying, so we just substituted in.
Yeah, like O to P here, O to P. Was this
Okay, sir.
-7 and -13?
Yeah, sir, I've got it.
Okay.
Thank you, sir.
Okay. Okay. Then they told us that and explain how such calculations help in accurate placement of facilities during road construction.
Okay.
Now,
Sir, I've got it.
okay, Namata. Now, what you need now to know is that when it comes to engineering things, for you to be able to determine the exact intermediate location between any 2 points, we mainly do these measurements using the ratios. So in order for you to determine exactly like the where to place that particular point is we use such calculations for measurement. So they ensure that all the different like maybe the installation point is put for that particular facility is put at the right location.
Okay, sir.
So this one at the end of the day, it helps to reduce the errors that they would have made. So
Okay.
Okay. Okay. So when you make such calculations, the errors are minimized. So you're able to reduce on the errors that are being made. Okay. So, okay, let me first speak. Yes, Samuel.
So good morning.
Morning.
I just have a simple question. Like after making the calculations as you have made, the question goes on and says, explain how such calculations help in accurate placement of facilities during road construction. Do you proceed with the statement and write it like you have said it, or how do I go about it?
Like after making the calculations, you go on and make that small 1 or 2 sentences, how they hope that maybe they are in position to determine the exact internal location where the point can be placed, thereby minimizing on the errors.
Okay, sir. Okay, thank you, sir.
Okay. And here now in your explanation, the word, that thing of internal makes your answer better. It shows that you have understood that this point is an internal installation. Yeah. Okay. 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 Do you want to do should this one be our homework, or we want to do it now? Should we do it now, or it is our homework? You can let me know, but we can. Okay, let's do it. No problem. We do it now. The trial number is here, Jovix. So first summarize. Summarize. Okay, Alvan says let's okay. Shop the number. Letitia, how do you know that you have to get an external? The moment you see that the ratio is the negative. We say that for negative ratio, it means it is an external division. And then we said that for internal, they're always positive. So in case in the question they mentioned that it is external, then for you have to go now, like even for this point, like the word extension point, it would have given you already a hint that that is external, even if they had not mentioned that the ratio is negative. So you have to pay attention to the wording. Yeah. Hope, Letitia, that's okay. Oh. Someone is asking, does it link to interpolation and extrapolation? Okay, a bit, just, yeah, a bit. That extrapolation is beyond and inter is within. Yeah. But that those ones for extrapolation and interpolation, we are mainly looking at gradients. Okay, I'm seeing Alex. Alex, yeah, Alex has got some answer there. Let me first, okay. Negative. Alex, can you first check again, Alex? Mainly on the I component. Yes, sir. That is okay. Gilbert, can you check out the I component? Bettina, that's okay. Hans, that's okay. Mattia, that's okay. Jan, that's okay. Anna, that's okay. Joyce, okay. Gloria, okay. Hasem, okay. Alvan, okay. Jordan, okay. Desire, okay. Hannah, okay. Rachel, okay. Samuel, okay. Martina, okay. Robert, check out something is missing. Alia, that's okay. Uthman, that's okay. Walter, that's okay. Mohozi, yeah. I think that's the answer. In case I don't know that we have anyone who is failing to get that answer. But the answers I'm seeing are really correct. Unless someone, in case you have a question, feel free to ask. Raise up your hand and then ask. Okay. Yes, Ruth.
Me, I'm failing to get the answer. I don't know
Okay.
why.
Okay, Ruth, first take us how you are approaching this number.
Okay. So
Mm.
I first drew the sketch. I don't know whether what I'm not getting is how to put the ratio. So I did a sketch, but I labeled the first part P to Q, but no. I have a, I don't know. I let my the outer point be A.
A,
So
okay.
yes, so there I have A.
Mm-hmm.
Then I start with then P, then Q.
Mm-hmm.
So I take here P to S, sorry, I have -2. Then I don't know, I got confused there. I don't know where 3 goes. Is 3 for A to, is 3 QA or PQ?
Like the whole of this.
Oh, it's 3, right? Yes. So in my working, I have 3 out of 3 minus 2. I don't
Okay. Now, when you reach here, Ruth, remember you are working with P and Q. So what you do, for you just be like cross multiplying that this -2 is going to go with Q. This 3 goes with the P.
Yes. That's when
So
I
you
got
see,
it. So I had 3
O to A
times
is
O to
3.
A is 3, yes. Times OP over. At me, I have there 3 minus 2. I don't know if that's right.
Very correct.
Then minus -2 OQ.
Now that's where you messed up.
Oh.
Because now since we have already brought the negative, here always it is a plus. For you just carry now your -2 OQ out of 3 minus 2.
Okay, thank you, teacher.
Continue and do for us.
Okay, so it's 3 into, what was OP? OP is 1, 1, 4, then plus negative, okay, minus.
Okay,
Plus
minus.
2 into,
Oh, okay.
there's a 2 there.
Okay.
Yeah, so I get 3, 3, 12. and minus 4, 12, 0. Yeah, then I'm able to get -1, -9, and 12. Thank you, teacher.
Okay. Okay. Yeah. So that's how you are supposed to do it. Okay. Then lastly, Gilbert.
Morning, sir.
Morning.
My question is that final answer, like since they gave P, P and Q as coordinates, are we supposed to give that that answer also as coordinates, or we are supposed to give it in terms of IJK?
Now, when you read through the question, they told that determine the coordinates. So you leave your answer like this in coordinates.
Okay, sir.
Okay. So that's what you do. Now, for explanation things, you can say it helps to actually determine the extension points beyond the existing infrastructure, such things. Also, you can say avoid reliance on approximations, such things. Those are the things you give for your explanations. Yes, Dorcas.
Good morning, teacher.
Morning.
Teacher, okay, I have understood everything that has happened here, but there is something confusing me about the extension point. I thought if you're dealing about that extension point, we're dealing about the external division. That's just.
Exactly.
And some time back, you're like, the result we have to put a negative.
Yeah, the negative. Are you saying this one is a negative? This is a negative, and this is a negative.
Okay. Okay, thank you, teacher. I thought we also have to make another thing a negative.
Oh, not really. As long as you note that one of the digits for the ratio is negative, that is automatically.
Oh, so I don't have to introduce another one.
Perfect.
Okay.
Perfect. Okay. Yes, Frank. I'm not getting you saying?
Like the explanation, I didn't get you clearly.
Oh, on the explanation. Okay. Members, this one I think just take a screenshot. This one take. What you want? Okay. This one we can take a screenshot. Okay. Frank, I was saying that for explanations, when they ask you, like maybe to explain its importance, what, you can just say that it accurately determines the extension point beyond the existing infrastructure, thereby maybe reducing on the errors, something like that. Also, you can say it helps in avoiding over-reliance on approximation. Yeah. So, have you taken a screenshot? When are we supposed to use IJK? Like you read through the item, in case you notice that the item, things were given in IJK, then you write your answer in IJK. When you notice that it was given in terms of coordinates, write through the coordinates. But also you read through the item, the task will be specific that we want coordinates or we want this. No, if the task says determining the vector, then you know that one you'll give your answer in a vector form, either in the column or in the IJK thing. Yeah, Chris, yes, the formula is the same. The only difference is that for one, you have to put a negative for m. Okay, are we good to continue? Hope people have taken a screenshot. Okay. Now this is just an exercise. You take also a screenshot. Okay, hope people have taken. The only thing for this particular number, the other previous number, what I wanted you to see was this word. That here, they have told that from station A to station B, to the distance from the verb, like you have A, you have the verb to B, that this is twice the other. So that's the only thing I was checking out, whether you can interpret that. So hope you have taken a screenshot here. I'm going to put another number, also take a screenshot for this. Now like here, when you look at this, you can notice that here, surely they want you to give your answer in terms of vector of I, j, and k. And when they tell you to get the distance, for all those numbers, they can as well tell us the distance from the fixed point. So that's when you go on and get the square root of x, y, and z. Clear, the ratios are there, but the ratios are in words. Like I've told you, twice this, twice this. So that is what gives you the ratio. That when they tell that the distance from here is twice the other. Like I was showing you that you'll find it is going to be 2 to 1. Yeah, it was indirect. Okay. Are we good to go, members? Okay, Kenna said not yet. Okay. Someone wants me to first go back here and they take a screenshot. Okay, take. Okay. Now we go to another number. Now, you can read through. They're telling us that we have this gentleman, Francis, who is a surveyor. And Francis has made boundaries OAB on the triangular form. Now, when you find such numbers, the first thing you are going to do is make your sketch. So I'm going to come up with a sketch for this particular number. So I'm going to come and I say, okay. So I'm going to first come up with a sketch. So my sketch is going to contain the things that I want. So I'm going to come here and I say, I'm going to draw a simple sketch because it is triangular in form. So you mark your O, mark your A, and mark your B. They told us that O to A is A, so that means O to A here you'll put A. Then O to B, you're going to put B. This is O to B, so you'll put here B. And then they told that points C and D are placed in the middle of OA. Hope you are noticing that points C and D are placed in the middle of O to A. So O to A, this is the point. O to A, so they have placed point C here. In the middle and AB respectively. So here where there is D, they have also placed a point D. If I may ask in the chat, what could be the ratio A to D, D to B in the chat? I want to see. What could be the ratio A to D? Very good. Because they have told you in the middle. Very good. So in the middle, it means that it divides into two equal parts. So that means this is 1 and this is 1. Similarly, here, this will be 1 and this will be 1. Very good. Now, we continue. Another point E is to be marked on B to C, on B to to C such that B to E. So I'm going to connect a bit. You follow my sketch. This is my B to C. Another point is to be marked on BC such that BE is 2 out of 3 of BC. Now, once you meet ratios given in this format, what you do, first write it in a better way, that B to E is 2 out of 3 B to C. Now, when it is in fraction, it may be hard for you. So first remove this 3 from here and take it back here. So that means you have 3 B to E equals to 2 to BC. Now, in ratios, you can, or if you don't do like this, another person would as well do like this, that B to E is equal to 2 out of 3 B to C. So you can remove BC by saying divide by BC, divide by BC, such that you get B to E out of B to C is equal to 2 out of 3. Now that means that this ratio is the same as B to E, B to C is the same as 2 to 3. That could be the alternative. So such that you know that if this is my point E, it means that B to E, I have 2 parts. B to E here, I have 2 parts. And B to C, I have 3 parts. So in the chat members, how many parts do we have from E to C? If I'm to move from E to C, how many parts do we have? Thank you, Santos. So, members, here we have just one part. Alternatively, someone who had done this one, for you what you do now for this part, what always you have to know that these 3 parts belong to BC. These 2 parts are the one that belong to B to E. You can interpret it like that. So the first item they wanted us to find, so here we have finished. And they have told us that Francis wants to know if point OE and are collinear so that he pays the surveyor. So, but the first thing they want us to find is find vector B to E. So they want us to find vector B to E. So that is the first thing we are going to find. Then from B to E, they want us to find O to E. Then from O to E, they want us to find B to D. Okay, I don't know whether I can move from this screen. So I'm going to go away from this screen a bit, and I put here, this screen here. And I want you to, I'm going to leave my sketch the way it is. Then I'm going to remove these things here, and then we start slowly. So, sometimes I want you always, you look through the question. Some answers are within the question and you must get them from there. So one of the answers you have to get, they told that to get the B to E is the same as 2 out of 3 of B to C. So in order for us to calculate B to E, we can use this kind of relation from there. So when I come here, I'm going to ask myself, but what is B to C? So that is the first thing I need to know. What is B to C? So what you need to do is find B to C. So we know that B to C, we say that B to C means start from B and move towards C. So I'm going to start from B, I go towards O. So that means I'll have B to O plus O to C. So what is B to O? Since we are going against the direction, that means that here we are going to have negative B plus O to C. But we say that O to A was A. What about O to C? O to C, since they told us that this point C was dividing the line O to A into 2 equal parts, it means it is 1 part out of the total ratio of 2 parts of the whole line of O to A. So that means that O to C is the same as a half of A. So here, this is the same as having a half of A. And this is our B to C. So let me first pick a hand from Bettina. Yes, Bettina.
Good morning, sir.
Morning.
But then for me, I request you make a recap from where you're getting the part things, those things, the ratios, before you continue to that.
Which ratio? Which ratio is confusing?
More sure that one of BE is equal to 2 out of 3 BC, that one.
Okay, don't go off, don't go off, don't go off. The rest, please feel free now to continue. Now, Bettina, are you seeing
Yes,
this? This was given
yes,
in the question, right?
yes.
So, Bettina, how can we remove this BC from here?
You multiply the 3 both sides, then it will cancel from one side. You get 3B is equal to 2BC.
3BE is equal to 2B to C, right?
Yes.
Is there any way we can have the letters on one side and the digits on one other side?
Yes.
What can we do?
Maybe if you're going to get BE, you're going
Mm-hmm.
to take 3 the other side, then it will become B, and also bring the BC this side.
Okay.
It becomes
Do.
BE
Mm-hmm.
over BC
Uh-huh.
is equal to 2 over 3.
2 over 3. How can you write the all of these things in ratio form?
B to E in a ratio of B to C
Mm-hmm.
is equal to 2
Mm-hmm.
in a ratio of 3.
So from B to E, how many parts do we have?
From B to E, like according to the line we have
From here,
2 parts.
2. Then what about from B to C?
3.
3. Now, when you look at our line, this is the line, which is B to C, and there is an E here. So Bettina, B to E, you have told me it is 2 parts, right?
Yes.
And from B to C, the whole of this, they have told us it is 3 parts.
Yes.
So what about from E to C? How many parts shall we have?
1 part.
1 part. Is the ratio
Yes.
now okay?
Yes, teacher.
Okay.
Thank you.
Okay. So that's how we came up with that ratio. So I'm going to remove this. Okay. Now we are going to continue. So from here, you can feel free to to collect like terms. If you want, you just go there and put. So that means we shall have BE equaling to 2 out of 3, and inside we shall have negative B plus a half of A. Now remember, this is a scalar, so it will multiply everything inside. So I'll have 2 out of 3 times like negative B plus 2 out of 3 times the half of A. So when you multiply, you'll get negative 2B out of 3. You notice these 2 here and these 2 here can reduce, so you remain with A out of 3. So this is our vector B to E. So you can write it in a very beautiful way by starting with a positive and end with a negative. But also this 3 can be factorized out since it is 3, so I can write it as A minus 3B. Or someone can write it as 1 out of 3 of A minus 3B. So sorry, this is 2, not even 3. Let me first remove this. Okay, let me first remove everything. Yeah, so you can write this as 1, okay, 1 out of 3 of A minus 2B, or someone can just write A minus 2B out of 3. But also when you leave it there, it is okay. But yeah, members, are we on the same page? Are we on? Yeah, Jackson says yes. Okay, 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 yeah, it is okay. You're going to allow me. I'm going to, because I think I'm going to use one screen. So allow me to go back to the next one. The next one wanted us to get O to E. O to E. Can we be trying out O to E? The rest, please always feel free to continue as you find O to E. Yes. Unmute.
So my question is that part B, why is BC equal to BO plus OC?
Why is
BC equal to BO plus OC? Why isn't it? Why weren't you doing it the normal way we're doing it?
why is BC equals to? Okay, what was the normal way?
Wasn't it OC minus OB?
Very good. Continue. What is your O to C?
Pardon?
What is like O to C?
I have OA.
Half OA minus what is O to B?
B.
B. We continue. What is O to A?
A.
Minus.
Now I get it. Thank you.
Okay. Yeah. So, but if you want, braid, it is okay. B to O, like we say that B to O is the same as negative O to B. Okay. Okay. Now we are going to continue, but I expect the rest to be on the track. O to E now. Now O to E, still feel free now for you to, let me remove this. Some people I know they are still writing the other side. So now when they give you those ones, feel free to first connect such that you see how the thing flows. So O to E is here. And always, you can use the root that you will notice that these vectors keep flowing from one to the other, one to the other. Now, when I come to O to E, you ask yourself, which journey can I use to move from O to E? So you ask yourself, which journey can I use? But here, I prefer using the journey where I have all the knowns. Someone can raise up the hand and you tell us. Okay. Yes, Dorcas.
I think to get O to E, we can move from O to B, then from B to E.
Thank you. Dorcas, continue.
Since our B to E is already known, and also our OB is known. So our OB is B. Then our B to E is what we got here. A minus 2B out of 3.
Okay.
Then here we can use LCM, whereby our LCM is 3, since B is out of 1. Then 3 divided by 1, we get 3. Multiply by B, we get 3B. Plus A minus 2B. Since 3 divided by 3 is 1. So 1 multiplied by this, we get that. Then we collect like terms. 3B minus 2B, we get a B. So we write, yes, B plus A out of 3. Then here we can pull out a third, then remain with A plus B.
Okay. Thank you, Dorcas. That is very correct. So that's how I expect you to have that part. Then the last part is B to D. So I'm going to use this side, B to D. The rest be finding out such that we get the same answer. So let me remove this part to someone to take us through B and D. Who's taking us? Okay, Patrick.
Good morning, sir.
Yes, good morning.
So for me, for B to D, I considered it since from our triangle B to D, we are told that it is a half A B according to the ratio. So B to D is equal to a half A B.
Pause the bit. Pause the bit. Now, Patrick, are you looking at the
Yes.
first letter here? It is?
Yes. B.
So what does it mean? Where are you starting from to move?
I start from B.
From B, going towards what?
D.
D.
Towards A.
And when you look at the line you have given us here, where does the line start from?
Starts from A.
A. Towards what?
A.
A. From A towards what? Towards B. Are you not seeing it?
I'm saying.
A. So I don't know that you are seeing the vision on this formula you are giving us.
Okay, so what if I said it is BD is equal to a half BA?
Perfect. That is very correct. A half of B to A. Good. Continue.
Yes. So we have to first find BA.
B to A.
So B to A is equal to OA minus B minus OB. And after that, now we have our line from our triangle. We see that O to A is A. Then minus B.
Yeah.
Then we just fill it up here. So we are going to say it is B to D is equal to a half. Then this expression for B to A.
Okay.
A minus B. That's it.
Thank you so much, Patrick. Yes, so that is how you do it. Members, always pay attention. Look at if it is B to D, your line cannot start from A and it goes towards B. That one can only be true if it was D to B. So in case it is D to B, you note that it will be in the same line, but the directions cannot what? Reverse. So you make sure that the direction of B to D is the same direction you have here. They must be going in the same direction. If they are going in the different directions, then that is not correct. So you cannot have B to D and this side you say a half of A to B. This B to D is going this side. But now the direction you B to D is going this okay, it's going this direction up. But this A to B is coming down. So you make sure that the directions are the same. So that's how you had to find those different points. Yes, Dorcas, you have a point?
Yes, teacher, I have a question.
Yes.
Like on what you just said. What if I use A to B, but then I get the like negative A to B?
Now that is very okay. You tell us that. First tell us that what you used. That one is very okay.
For me,
You
I
said
had
B to D.
Is equal to negative a half of A to B.
That is very correct. Continue.
Then negative a half is like into brackets. OB minus OA. Whereby my negative a half, like negative a half into brackets B minus A.
Okay.
Yes, teacher. And I end it there. I don't know. Should I continue? Like I make this negative.
Yes, you continue. You make it beautiful.
Half into negative B. Then I find a half into A minus B.
Yes. That is very correct. Okay. So, members, that's how you have to do that. That's how you have to do that particular one. Okay. Then the question was asking, should Francis pay the surveyor? Now, when you read through the question, you notice that the question was indirectly asking you to prove collinearity because the condition for him to pay the points the points O to E to D must lie along the same line. So yesterday we looked at collinearity. So, and we said that for collinearity, you first prove whether those points lie along the same line. So how are you going to prove it? I don't know whether I have space. I don't know. I want to remove something such that, let me remove this thing in the middle. Let me remove this thing in the middle such that, yes, so you prove for collinearity. Can we prove for collinearity? Let everyone first prove, and you tell us what you are coming up with. First proof, and then, and I told you for collinearity, first draw O, E, and then D. And we said here, feel free to say that I'm going to use O2 E is equal to K E to D. Yeah. If you don't want to use this one, I don't know that we have E to D. In case this one does not work for you, then you can another person can say O to E equals to K O to D. That is another option. Don't stick on one. You say O to E and O to D, as long as you have a common point. In case you notice that, I don't have E to D, it may take me my time. So then you say, let me use another option. So feel free to use the option that will make your work easier. Because you are going to notice, hey, Lydian, we said K is the scalar multiple. If you are here yesterday, we said that for something to be parallel, there must be a value which when you multiply with the other vector, you get exactly the other vector. So I don't know whether people are noticing that there is no any way you are going to be able to get to the answer without getting either ED or D. So make sure you get one. Either getting ED or D. You must have one. Okay, and I'm going to go back, and I'm going to go back. Linda, unmute. Linda. Linda, if you could unmute. Yes, Linda. Unmute. Linda, you are not. Linda, unmute. Okay, I've failed to get Linda. And now, okay. And now I can expect you. In fact, members, can we use this beautiful one, O to D? Now, O to D, can you use the ratio theorem? Use the ratio theorem. Let's hope that's what we have used to get O to D. I expect you to utilize the ratio theorem for that. People get Ronald is getting 2 to 3. Okay. Okay, Linda, now it is fine. For O to D, use the ratio theorem. Because you have the ratio of A to B. That one, and that is an internal what? Division. So you can use your 1, 1. Okay, the ratio theorem is what we have just looked at. Hope you have not just come in. Ken, are you just joining? Mm. Mm. Edward, O is here. We have already obtained OE. So for O to D, I expect you to just do like this, that O to D is equal to, when you come this side, ta, you'll have O to A out of 2. Then plus O to B out of 2. That you have OA and you have OB already. So this will give us A out of 2 plus B out of 2. I don't know what you are getting, members. But this is what I expect you to have, which is a half A plus B. And when you look at our O to E, members, you notice that O to E was a third of A to B, and this is K, and O to D was a half of A plus B. So you notice that these two vectors are the same. So at this point where I am, I can just equate corresponding vectors, that this is vector in A and this is vector in A. So I can say I'm equating A's is equal to K out of 2. So when I cross multiply, I'll have my K is equal to 2 out of 3. So those having K 2 out of 3, you are very correct. Ken, we have done ratio theorem today. For scalar multiple, okay. 2 out of 3 is okay. Yes, like Ken, we say that these two are the condition for something to be called parallel. That parallel vectors means that when you get a given number and multiply it with that, like in case I have two vectors, let me say I have vector A and vector B. These are my two vectors. That for something to be parallel, there is some number which when I multiply with one vector, I get exactly the other vector. So that's what we are trying to do here. That there is that number which when I multiply, I get exactly the other vector. So, but I'm going to advise that you can revisit yesterday's recording such that you can be able to pick more from that. Yeah. Also, the first condition works. All these two conditions work. But for me, I always look for a shortcut, which one gives me the answer quickly. So even if someone had used E to D, now when you look at the second option, where you have E to D, this one, why I ignored it, it's going to come. Like you're going to first ask yourself, how can I get E to D? Now to get E to D, you have to come get E to B, then get B to D. That's how you can get it. So maybe in case I'm to remove this, it also gives you the answer. It is also very fine. So you know that E to D, I can use E to B, then plus B to D. But when you look at E to B is the negative of B to E. So this is the same as having negative of A minus 2B out of 3, then plus your B to D, which is a half of A minus B. Then you work out the mathematics that this is negative A plus 2B out of 3, then plus A minus B out of 2. So when you work out the math here, I'm doing it quickly. When you work out your math at this point, you are going to notice that the LCM is 6. So if you have 6, this is going to be negative 2A plus 4B. Then here you have 3A minus 3B. And here you have negative 2A plus this, which will give you a 4 minus that. It will give you a B out of 6. So this is your E to D. So when you come here to substitute for your E to D, still it's going to be the same thing. I'm going to first remove this. So when you come there, you are going to find that your O to E is a third of A plus B is equal to E to D, which is K into A plus B, everything out of 6. So when you equate the A's and the A's, then it means you have a third is equal to k out of 6. So you'll note that k is equal to 6 out of 3 by 3, 1 by 3, 2. So yeah, I think, yeah. So you end up with something like that. So it's still there is a scalar value. I don't know that you have all got it. That now, for it to be O to E is equal to 2 to E to D. That means that from O to E, you have one part. Like from O to E, you have two parts. Here you have two parts. Like the whole of this line, O, this is E, and this is D. So you notice that from O to E, you have two parts. And E to D, you have one part. Then for the first one, we obtain O to E was equal to 2 out of 3 of the line O to D. So when you do the mathematics, you find that this is 3 O to E is equal to 2 O D. So which means that O to E, you have two parts. O to D, you have three parts, which is the same thing. Let me hope that math is okay. Bree? Those who are getting 2 is also very fine. 2 is very okay. So those who have used the first condition, here you get 2. Those who have used the second condition, here you get 2 out of 3. All of them are correct. Okay. Members, are we on the same page? Yeah, but when you go back and interpret, hope Lydian you have seen. Lydian. Hope you have seen. I don't know that it is okay. Lydian, you can unmute. So they are the same things. 2 and 2 out of 3. A third, which a third? The third came from like O to E, we had this. O to E. When you go back and look at the expression we got for O to E, we had a third of A plus B. Yeah, so that's where that third came from. Hope Ron, that's okay. When you go back and check when we are finding O to E, we had that. Yes, that is very possible. Take an example. In case this was A plus B and this vector was A plus 2B, then those vectors cannot be collinear. When you look at these vectors you have remained with, in case this is A plus B and you had maybe obtained this side A plus 2B, then those vectors cannot be collinear. Because for collinearity, when you equate the vectors in the I and the I, the same answer must be obtained for J and then the J. So when do we have same scalars for both columns? Alvan, I've not gotten your question very well. Alvan, you may unmute.
Yes. Good morning.
Yes. Morning.
My question is, like, I thought for these points to be collinear, we should get the same value for k in both conditions. So if they are collinear now, which other condition or question answers where we have both in both conditions and we have the value of k being the same?
Oh, okay, stay on. Now, one thing you need to know is that when you look here, Alvan, this is O to E to D, right?
Yes.
Now, what did we obtain? You notice that we obtained that O to E is the same. For the first one, we obtained this, right? And
Yes,
for the
sir.
second one, we obtained this. Was it 2 out of 3? O to D, right?
Yes.
Now, what matters or what is very important is to make sure that the ratio you get here and here is the same for both the conditions. So when you use the first one, you notice that this is O to E out of E to D is the same as 2 out of 1, right?
Yes, sir.
So from O to E, how many parts do you have?
From O to E, I have 2.
2. And then E to D you have?
1 part.
One part. When we come this side, O to E out of O to D is equal to 2 out of 3. So from O to E, how many parts do you have for this part?
I have 2.
2. Then what about O to D? How many parts do you have?
I have 3, like 3 in total.
In total. So how many do you remain with here?
I remain with 1.
With 1. Yes. Now, as long as those two things are the same, then it is okay. Number 2, you cannot have the same values for scalar if you have used different what? Conditions. The values of the scalar cannot be the same.
Oh, so the ratio is then just to be the same.
Aha, the ratio is the one that has to be the same.
Oh, okay. Thank you, teacher.
Okay. Yes, Deborah? Deborah, unmute. Oh, I'm failing to get to Deborah. Okay. Anyone with a question, please, you may ask now before I give you the last number for your homework. Okay. Deborah, you are not unmuting. Okay. Hope, Abdu, you have obtained it very well. The explanation why they are not the same. Okay. So, Deborah, you are not unmuting.
So good morning.
Yes, good morning.
Teacher, I'm requesting for pardon on the ratio formula here on OEED. Just a little recap.
Okay.
Yes, teacher.
You have said the recap on O2 E.
On the ratio formula, where the 2 and 1 come from, like that.
The 2 and the 1. Here down O.
Yes. No, up, that one. O
This
to
one.
E to here down where you had come and said it's O to E, then E to D while you were explaining to the previous person. So I was just confused where the 2 and 1 comes from.
Here.
On the simple graph, on the simple illustration.
Here.
Sorry. Yeah.
Here. Hey.
Yes,
Okay,
teacher.
now that one came from here. That since we had obtained our value of K as 2. So when we came back here to substitute for this condition, where was K? We had placed our 2. Fine? So we ended up
Yes,
with
teacher.
O to E is equal to 2 to E to D. But now what happened is that we wanted to know the ratio. So what I do, I remove this E to D. So when I remove that E to D, I will divide here by E to D. I divide this side by E to D. So here I remain with O to E out of E to D. Now, ED divided by ED, we get 1, right?
Yes, teacher.
So that's why we get 2 out of 1. Now, in ratio form, when I'm to write this, I write it as O to E to E to D, which is 2 to 1. Now, this means that from O to E, you have the 2 parts. And then E to D, you have 1 part. So that's where it came from.
Oh, thank you, teacher.
Okay. So allow me to display number here that you are going to try out, but I'm going to first clean the screen. Yes, Brian. I don't want to clean the screen if this is your question. Brian?
Teacher.
Yes?
Excuse me. Excuse me.
Yes.
Like I have
Go on.
I missed out the first lessons.
Oh. Now those ones,
I
let me
missed out
clear
the
the board.
first lessons. Now how can I get to them?
Hey, now those lessons are available on YouTube.
Okay, like how can we search for them?
Okay, holistic e-learning platform.
Okay, thank
Okay, but we share them on the group on a daily basis. Okay, members, take a screenshot of this. You are going to try out this number. Thank you, Ruth. That is correct. Comfort, the answer is okay. Just use one because the answers are the same. Oh, do not forget to conclude on the other number. I'd forgotten. Do not forget to conclude. Let me take you back a bit. Should Francis pay the surveyor? Then your answer should be yes. Francis should go on and pay the surveyor because the points O to E to D are collinear. And then you should approve for collinearity because there is a point E which does this and this. Yeah, so you should be able to pay. But do not forget that you need to respond that yes, he should go on and pay the surveyor. And then you give the reason or the justification for your yes. Okay. Have we finished to take a screenshot? Oh. Okay. So, members, we are going to end here. We are going to end here, and then we shall start from there.